Hi students, this is Sirisha. I hope all are well. Please stay in home and save your lives, okay? Now I am going to explain third unit, that is fiber optics and electromagnetic waves. We have already covered some of the topics in our class. So now I give briefly all our covered topics in classroom, okay? So come to third unit, which is nothing but fiber optics and EM waves. EM waves means electromagnetic waves. So in that first we have explained fiber optics. So optical fiber. Optical fiber is a thin and flexible optical medium having cylindrical shape. So it is a thin flexible optical medium having cylindrical shape. It looks like this. Okay. Next one. Optical fibers are used in communication, medical endoscopy, sensors, and they are also used in coherent bundles also. Okay. Next. Communication. Come to communication. Optical fibers are used mainly in communication. So what is meant by communication? So communication means we are sending information from one place to another place. So another place there is a receiver. So we are sending information from one place to another place via a channel. So via a channel. So what is communication means? We are sending information from one place to another place using a proper channel. Here our optical fibers works as a channel. Works as a channel. So this is also known as role of optical fibers. So what is the role of optical fibers in communication means optical fibers works as a channel. OF means optical fibers. So these optical fibers works as a channel and the role of optical fibers is also known as channel. So why we are chosen optical fibers as channel? So that is our question. So why we are chosen optical fibers as a channel in communication process? So in every communication process, when we are sending information from one place to another place, the channel must allow the all frequencies. The channel must allow the all frequencies. That is the one of the main property of channel. So next one. When we are sending information from one place to another place, the loss should be, that loss is also transmission loss. The transmission loss should be low. So that is the another one. So there are two very important points we should maintain when we are sending information from one place to another place. One is the channel should allow all frequencies, and when we are sending information from one place to another place, the transmission loss also should be small. Then only we get proper information from the transmitter. Transmitter is nothing but which is the information source. Transmitter is nothing but which is the information. So when the transmitter sends information, the total is received by the receiver. So when the receiver receives total information means when we maintain these two parameters. So the channel should possess high bandwidth. The channel should possess high bandwidth. Next one, the transmission loss should be low. So these are the two important parameters we have to maintain in communication. These two properties are satisfied the optical fibers. That's why optical fibers are chosen as a channel. Okay, clear. Next, what is the working principle of optical fiber? Come to that slide. So, optical fibers works on the principle of total internal reflection. So, optical fibers works on the principle of total internal reflection. So, this is very important. So, these optical fibers works on the principle of total internal reflection. So, to understand this total internal reflection, first we have to understand this diagram. So, first this is medium 1 and this is medium 2. These two mediums are separated by a boundary. So, this is the boundary between medium 1 and medium 2. Medium 1 is chosen as denser medium. So, very important, medium 1 must be chosen as denser medium. Medium 2 is must be chosen as rarer medium. Okay, and this is the normal drawn to the boundary. This is the normal drawn to the boundary. Next, when the light ray is incident at the boundary and it is traveling from denser medium to rarer medium. So, this is the light ray which is traveling from denser medium to rarer medium and it is incident at the boundary with an angle of incidence I. So, this is the light ray incident at the boundary with an angle of incidence I. Here mediums are different. So, that's why at the boundary the ray is bending, that is known as refraction. Here the light is traveling from denser to rarer, that's why the refracted ray is always refracted away from the normal. Very, very important. The refracted ray refracts away from the normal. So, this ray is the refracted ray. This ray is the refracted ray. Next, when the angle of incidence is increased, the angle of refraction is also increased. When the angle of incidence increases, the angle of refraction also increases. So, we are continuously increasing the angle of incidence. The angle of refraction also increases. At a particular angle of incidence, the refracted ray touches the boundary. The refracted ray touches the boundary. That angle of incidence is called critical angle, theta c. Theta c is nothing but critical angle. So, what is critical angle? Which is nothing but angle of incidence. But at that critical angle, the angle of refraction, theta r, come to this diagram. The angle of refraction, this is the angle of refraction. This must be equals to how much? 90 degrees. This equals to 90 degrees. So, what is the condition? When I equals to theta c, then theta r equals to 90. So, this is the condition for critical angle. So, when the angle of incidence equals to critical angle, then angle of refraction equals to 90. Clear? Next, furtherly, when we are increasing angle of incidence above the critical angle, the ray comes to the same medium. The ray comes to the same medium. So, this is called total internal reflection. This is known as total internal reflection. So, that means the ray is completely reflecting into the same medium. So, that's why this phenomenon is called total internal reflection. This is possible in optical fibers. So, optical fibers works on the principle of total internal reflection. Come. So, next one, there are three conditions. When angle of incidence is equals to critical angle, when angle of incidence less than critical angle, when angle of incidence greater than critical angle. So first one, when angle of incidence is less than critical angle. Second one, when angle of incidence equals to critical angle. Third one, when angle of incidence is greater than critical angle. So in the first condition, what happens? Refraction takes place. Second condition, this is known as the critical angle. Refracted ray touches the boundary. Okay. In the third case, total internal reflection takes place. Okay, clear? So when angle of incidence less than critical angle, refraction takes place. Equals to critical angle, refracted ray touches the boundary. Greater than critical angle, total internal reflection takes place. So, thank you.